Welcome to the General Chemistry 1 class. This section is on the electronic structure of atoms, focusing on the quantum numbers part 2. In this lesson, we will use quantum numbers to describe an electron in an atom.
Recall that the four quantum numbers are the principal quantum number, angular momentum quantum number, magnetic quantum number, and electron spin quantum number. The first three quantum numbers describe the energy level, shape, and orientation of the orbital a certain electron occupies. The fourth quantum number describes how an electron spins. The concept of electron spin gave rise from observation noted when an electron is subjected to magnetic field. Zeeman effect. An emission line of elements undergoes splitting into two or more lines in the presence of magnetic field. This observation is known as the Zeeman effect, which was named after the discoverer Peter Zeeman, a Dutch physicist. In the early 1920s, Otto Stern and Walter Gerlach made an experiment revealing that atoms and its subatomic particles have permissible orientations. In their experiment, a sample of silver, with an odd number of electrons, was heated up to its gaseous state. The beam of hot silver gas passed through a non-homogeneous magnet, causing the beam to deflect into two opposite directions. These beams were of equal intensity when hit a screen, suggesting 50% of the atoms are deflected by the north magnetic pole, while the other 50% of the atoms are deflected by the south magnetic pole. With the existing concept in classical physics that a charged body creates a magnetic field as it spins on its axis, Samuel Godsmith and George Allen Burke theorized that an electron can be thought of as a charged sphere rotating on its axis, either clockwise or counterclockwise, with the angular momentum the same in magnitude for all electrons. Such postulate about spin of electron gives rise to another quantum number called the electron spin quantum number. This quantum number can have a value of positive 1/2 or negative 1/2, corresponding to spin up or spin down respectively. An electron is in a spin up direction if it aligns with the applied magnetic field, and in spin down direction when it aligns against the applied magnetic field. Example number 1. Identify if each of the following sets of quantum number is permissible or not. For A, we have principal quantum number is equals to 4, angular momentum number is equals to 4, magnetic quantum number is equals to negative 1, and for electron spin quantum number, it is equals to positive 1/2. Also, we have B, which principal quantum number is equals to 3, angular momentum number is equals to 1, magnetic quantum number is equals to 0, and lastly, we have electron spin quantum number is equals to negative 1/2. Solution for A. For principal quantum number, we have 4. So, permissible values of angular momentum number are 0, 1, 2, and 3. Since angular momentum number have a value of 4, then the set of quantum numbers are not permissible. Solution for B. For principal quantum number, we have 3. For angular momentum number, we have 0, 1, and 2. Thus, angular momentum number is equals to 1. It is permissible given the value of principal quantum number. For angular momentum number, we have 1. For magnetic quantum number, we have negative 1, 0, and 1. Thus, magnetic quantum number is equals to 0. It is permissible for the given value of angular momentum number. Possible electron spin quantum number values are either positive 1/2 or negative 1/2. Thus, the given of electron quantum number is equals to negative 1/2, it is permissible. Therefore, the given set of quantum number is permissible. Pauli exclusion principle. Wolfgang Pauli, an Austrian physicist, postulated that no two electrons can have the same set of four quantum numbers. This is known as the Pauli exclusion principle. For an electron with a given value of principal quantum number, angular momentum number, and magnetic quantum number, possible electron spin quantum number values are positive 1/2 and negative 1/2. With this, an orbital can be filled with up to two electrons, and these electrons must be of opposite spins. Electrons in a subshell. As a consequence of the Pauli exclusion principle, the number of electrons that can be held in each subshell is twice the number of orbitals present in that subshell. In other words, a subshell with a certain value of angular momentum number can be filled with up to 2 times quantity or 4 times electrons. Thus, the permissible value of a subshell which has one orbital can accommodate up to 2 electrons, while the permissible value of p orbital with 3 degenerate orbitals can hold up to 6 electrons, while the permissible value of the subshell with 5 degenerate orbitals can hold up to 10 electrons. And lastly, we have permissible value of F subshell can hold up to 14 electrons, and so on. Electrons within a shell, the maximum number of electrons that can be accommodated by the nth energy level is 2n squared. Thus, 2 electrons can be accommodated in the first energy level, 8 electrons in the second energy state, 18 electrons in the third energy state, and so on. To summarize the electron spin quantum number, it describes how an electron spin in an orbital. We have here our references or bibliography for further reading. That's all. Thank you.